Uh, Welcome to this two-day workshop. Allow me to give you a broad outlook of what is our goal for this next 2 days. For the next 2 days, I am going to provide you with some snapshots of how you can use Python to solve problems in geosciences and generate programs that will be able that you can use repeatedly for data sets, analyze data, generate plots that you can put directly in your thesis or your dissertation or your report or your uh, classwork, whatever it is. It doesn't matter. For whatever project you are involved in, you can utilize Python to solve certain problems that you are facing. Obviously, there is no way in the next 2 days I can show you everything of Python, and neither do I promise that during the 1 month course that I will be able to show you everything, because 1 month is not enough to show all the possibilities of Python and then add all the applications of geology in Python. Now, before I start, I want to ask a quick question just to gauge where things stand and where I should start and where I should aim for. If people can write in their chat box, are they familiar with Python programming, or they are new to Python programming? Just if you can say beginner, intermediate, or advanced, like you are like a complete beginner, you have no background knowledge of Python, versus intermediate, you know some, and then you go on to advanced. Okay, I'm seeing intermediate and advanced a lot. Okay, there are some beginners. Okay, so now the beginners are catching up. Okay, Gabriel, you should be able to catch up a lot quicker. All right. Okay, so somebody's Neeraj Mathur is familiar in C, Java user. So if you are familiar with any other programming language, the transition for as far as the programming is concerned will be very easy. The rest is your familiarity with the geoscience problem that you are trying to solve. So that should not be a problem. But again, as we have seen repeatedly during these courses and these workshops, we have a lot of beginners, which is fine. This is just for me to get an idea of how to kind of plan the course over the next 2 days and the 1 month course as well. Now, what I will show today is going to be some basics of Python programming, where I will introduce the basic concepts of, printing, doing some calculation, and then we are going to go in and write a couple of models. So, for example, what do I mean by a model in the context of a Python course like this, where there are intermediate level programmers here? So a model would be, for example, let's say you have a plane, and on that plane you have a stress vector, and that vector can be decomposed into a normal vector and a vector normal to the plane and parallel to the plane. So those are your normal stress and shear stress. How do we do that? How do we computationally do that? How can we model what would be the values for the shear stress and normal stress if I know the magnitude of the vector and the angle the vector makes with the plane. Okay, particularly the acute angle the vector makes with the plane. So those are some of the questions. So another problem which we won't go into the details and nitty-gritties of is how do you calculate the lithostatic stress or lithostatic pressure inside the earth? Now, you would say, well, that's a very easy problem. It's just you take the density times the depth times the acceleration due to gravity. Well, I'll turn around and request you to reconsider that, because as you all are aware of, as we increase depth, the density changes. So does the acceleration due to gravity. Now, how do we take those into consideration? Well, that involves solving a definite integral. Now, not that all of us have remember how to do that integration by hand. We don't need to anymore, because with Python, we will demonstrate how we can do that very easily and actually look at what is a realistic solution of the lithostatic pressure at depth for a crust. Now, another big thing about using Python in geology is data analysis. Almost all of you have some sort of data that you have collected either in your lab or in your field, and you need to perform some statistical analysis. Perhaps the simplest one that we know is the linear regression, which is also known as the least square regression. Now, we will actually see how we can do that when you have 50 elements that you are trying to plot the correlation between. So, for example, we can generate what is called a covariance matrix, and then we look at the correlation matrix. And the matrices, instead of being a bunch of numbers, we will plot it as a heat map. So you can look at it and then say, oh, okay, so these two elements are better correlated than the others. Then tomorrow I have exclusively set aside for visualizations, which is what Mr. Nikhil was showing you with some of the videos, where you can take some elevation data and then generate a 3D map of a region. So, for example, one of the things that I will be showing you is we'll take some elevation data for Mount St. Helens, and then we'll wrap a surface on top of it, and then we will create some color contours for the different elevations. Another thing that I will try to show you is that how we can draw a cross section along that, or rather a topographic profile along that along the topography, and kind of look at what is the variation in elevation along the x-axis. And if time permits, I want to show you. So this part that I just talked about, the cross section, the plotting of the elevation, and all of that. For that, we will be using the library called PyVista. And then the last thing that we will have time to look at is another library called GemPy, where you look at drill hole data, and you take drill hole data and then you perform kriging at again, we are not going to go into the deep mathematics of kriging because 2 days is not enough for that. But we will try to generate these geometries that we can see from that data. So that's the plan for the first these 2 days, which is supposed to be a primer, or to kind of give you a taste of what is going to happen in the longish course. In the longish course, of course, we are going to go much slower. We are going to go through every little thing, and we'll cover Python up till functions. So neither in this workshop nor in the course, we are going to cover object-oriented programming, because honestly speaking, at this level, you don't need it. As long as you understand functions, NumPy, Pandas, Matplotlib, You have enough firepower to solve any and all problems that you have come across. And obviously, time is a factor. And then all the visualizations will be discussed in the month-long course. Okay. I welcome questions. So if you have any questions, just ask. Don't say, excuse me, can I ask a question? None of that is required. Just simply ask, why are you doing this? What is this? What about that? Whatever question you have, please ask. As far as questions are concerned, I can answer technical questions regarding the course. When does the course start? What time does it start? What are the fees? This and that. You would have to wait until the end of the workshop. At least when I finish the workshop for the day, today or tomorrow, you will have to ask Pragati and Mr. Nikhil those questions, because I don't deal with that part of things. All right. So without further ado, let's jump in. I am not going to show you installation of Python and all of that in this particular workshop, again, in the interest of time. But what I am showing you here is called a Jupyter notebook. Essentially, this is like your standard handwriting notebook that we have, where you can pass some commands, and those commands are sent to the Python kernel, which is the heart and brain and soul of Python, if you will, that processes all your instructions and then gives you an output. All right. Now, in order to do that, there are various things that you can do. So you can see that I have this code option highlighted. That means Python is expecting anything and everything that I type into these rectangular boxes called cells to be Python code. That means Python will understand what that is. Okay. I will not talk about Markdown now. We'll talk about Markdown in the course itself, which is a very useful thing to know, so that you can essentially develop a write-up as you are writing all your Python code. If time permits, I will show you a very quick preview of a notebook that I've converted into a PDF to show you what can be done. All right, so without further ado, let's jump in. And the first thing that I typically start off with is by writing a comment. Now, there are a couple of ways in which you can write a comment. So the pound sign, or let me increase the font size. Hopefully everybody can see it now. So the pound sign or the hash key or whatever you say, it's the symbol above the number 3. That is for a single line comment in Python. Now, in this case, Python will simply, once it encounters that pound sign, it simply ignores whatever is there next. Okay. However, if I press return and then start writing see, Python suddenly starts to give some color to the commands. Okay, that means the single line comment is valid until a return key is pressed. Okay, so as long as the return key is not pressed, it considers it as a single line of instructions and will simply ignore it. Now, if I execute this line of code, which is by pressing Shift Enter in this particular case, I get the response, hello. Now, what is this print and what is this hello business going on? So oftentimes, we want to communicate with Python by generating some prompts. And these prompts are typically very useful when you are writing large amounts of code to kind of help yourself when you come back to debug them later. Okay. So for example, I will write a very simple print statement where I would say, welcome to the workshop on Python geosciences. Geosciences. All right. And, then again, I execute that. That gets printed out over here. Now, what if you want to write multiple lines of comments, and they are very useful, like what? So a few seconds ago, I explained that we will be solving a particular problem where we will be looking at how we can take the magnitude of a vector and the angle the vector makes with the plane and do a bunch of calculation. Now, in Python, there is no way for you to write out all the formulas. We don't always memorize all the formulas. There could be a problem where you want to write out the problem. So for that, what you can do is use this trick of triple quotes. Now you can use single quotes, you can use double quotes. It doesn't matter. I personally prefer the double quotes because it kind of helped me understand, okay, these are quotations and these are just statements that I am making. So for example, I'm going to write here something very simple. In this workshop, we will look at how to determine or how to model. Now see, I am almost about to run out of space, so I'm going to press enter. Okay, how to model the normal stress and shear stress acting on a plane. Okay, given the magnitude of a stress vector and the angle between the stress vector and the plane of interest, or the and a plane, let's say, and the plane. All right, now that's quite the mouthful. Now, this will be helpful in your program, because when you write the program, you would know, okay, this is what I started doing in this particular code. When you come back to the code 3 months, 4 months, 5 months later, because I have a code that I have written and I've completely forgotten what it does. Even the name of the file that I have, particularly if it's a Jupyter notebook file, it's challenging. Later in the course, you will learn how to write standalone files, which are just .py files, where you just write a bunch of code for solving one problem or multiple problems, however you have set it up. But the name, that little small tiny something.py, you won't remember what it does. But once you have written something like this, that makes your life a lot easier. Now, look, there is something very interesting going on here. Every time I used the return key, Python recognized it and is putting in that. It's telling you that these are the places you have used a hard return to go to the next line. All right. Now, this might come across to somebody that, well, that's kind of ugly. I really don't want to see a \n. The backslash is an escape character, tells Python that we are doing something other than just simply typing. And the n tells Python that you have to go to a new line. Now, for that, the solution is to write a markdown. Again, I'm not going to talk about markdown, as I said, in the interest of time. Now, let's go on to the next thing. Again, most of you have some experience with programming language, or even if you are a beginner, because you are all science graduates, I am not going to insult you by showing you how to add, subtract, multiply, divide things in Python. What I will show you are the interesting stuff is when you want to solve something to the power of something. So I will show you that that's how you resolve the power of something. Okay. Now, let's make this a little more fancier. Let's say number equals, or I don't know, power equals to 3. Okay. Then I'm going to say, I'm going to do something a little fancy here. I'm going to use what is called an F string. Again, we'll go into all the details in the course, but just to give you a flavor, I can now write, actually, let me do this. A equals 2, B equals 3, then I can say P. Now see these things, A, B, power, and all of these things in Python language is called a variable, or it's essentially a label to kind of act as a placeholder for certain values. So in the placeholder, this A is a label to this number 2. But for us humans, it is easier to think that I am assigning a value of 2 to A. Okay, so that's how we think about it. Now, not only can you assign values, you can assign functions as well to variables. Okay, so this variable power now contains this little mathematical gymnastic that Python can perform. And here I can write this that the power, no, I can say the mathematical operation A raised to the power B results in that. Now, the beauty of all of this is immediately Python understands what you are trying to do. So if I execute this line of code, you will see it tells you it's actually telling a story. So the mathematical operation 2 raised to the power 3 results in 8. Now, as we do further computation, you will come across decimal values, scientific values, and there are ways in which you can work on the formatting. So for example, I'll show you an example, a quick example. If I can get there. Okay. So if I put a colon here, that means I am trying to do some sort of a formatting. Okay. And if I say 0.1f, now you would say, what is this 0.1f? You will see that in a second. Okay. And if I say colon 0.1f, and I say this is 0.2f, and I'm going to make this 2.0, 3.0. All right, then I execute this. Now look, it has suddenly understood that I am trying to put a format, and it puts a decimal point and a 0 next to it. So this is 0.1f essentially means, or I need to go one digit after the decimal. Okay, and similarly, if you remember the way I had it set it up, the last one, power, the formatting I had it set it up as 0.2f. That means there is going to be 2 of these. Now, what are my options? Well, there are several options. If it's an integer, you can select the number of digits it's going to show. If it's a float or a decimal, you can set the decimal. I have shown you just that. If you have a scientific, if you want to plot the number, if you want to represent the number in a scientific manner, you can do that. Again, those will be discussed in the later sessions. All right. Now, can these variables be discussed in any other way? Well, there are certain rules that we cannot use we cannot use what is called keywords as variables. Now, what are the keywords? Again, that would be something we would discuss in the main course itself. But there are certain keywords that we can't use, like, for example, true, false, class, break, if, while, for, because those are strings that are used that have certain meaning for Python. Okay. So let's actually try to solve a problem. So the simplest problem that I can demonstrate to you without, confusing people, before I jump into that stress problem that we were talking about, is to simply convert Celsius to Fahrenheit. Okay. Well, I mean, this is a simple example for the beginners. The intermediate level people will get a chance to whet their appetite when we talk about this stress problem. So this is again, I can, there are two ways of doing this. One is temperature C. So again, note how I am assigning a variable. I'm not just throwing in a variable out there randomly. The variable must convey some meaning back to me. Okay, so temperature C means temperature in degrees centigrade. And so there are some good best practices that you will see as I start writing this code, that the temperature C is, let's say, I don't know, 500 degrees. And then what I do is I write that this is in centigrade. All right. So that you can come back later in your code and know, okay, what is this 500? What is this temperature C variable? And what is the unit of 500? So you can kind of keep track of it. All right. Let's make my life easier because I want to show many examples. I'll do this just Kelvin. Okay. So then I will say temperature underscore Kelvin. We know that it's just centigrade plus 273.14. And you just put that number in. And as usual, you can put in this Kelvin. Now, this is not necessary. You don't have to write this comment of centigrade or Kelvin. This is for you to keep track of what is going on in each line of the code. Okay. For beginners, my advice would be that 50% of your code should be comments, so that you remember why you wrote this code, what exactly does this code do in every block of the code. Okay, because I don't need, so people who have done intermediate level programming, they don't need this convert Celsius to Kelvin. They can see this expression and figure out what is going on. But it is good practice to kind of keep track of things, because 2 years down the line, suddenly somebody says, oh, what did you do? And then you are like, oh, what did I do? I don't remember. But these comments are actually going to help you out. So then you are kind of printing the solution. What I would say again is, this is an F string, and we are going to write degrees centigrade converts to okay, degrees Kelvin. Okay. Now note, I didn't put in any kind of formatting in here. Okay. Now, if you want to, you can. So let's do that. So let's say 0.2, whoops, 0.2F. Yes. Now, if I execute that, you can see 500 degrees centigrade converts to so and so degrees Kelvin. All right. Now, let me find out the stress solution. Again, for the interest of time, I have to kind of cheat a little bit, kind of look things up because we are going just super fast. Uh, problem. Okay. That takes care of that. I saw that. Where did I put it? Aha. Now I remember. Yes. Okay. So now, so let me write this down a little bit about how we are going to solve this particular problem. And now, as you understand, so let me say that we are going to calculate the normal and shear stress. Okay. Now, to do that, we need certain pieces of information. So the first thing that we need is magnitude of stress vector acting on a plane. Okay, that's the first thing that we require. The second thing I need is the angle between the plane and the stress vector. Okay. Now, the moment this happens, this angle business comes in, I have to note a couple of things. Humans prefer angles measured in degrees. However, computers prefer angles measured in radians. All right. So this conversion business is involved. Now, how do I do that? So then somebody will say, oh, we know how to convert the from degree to radians and radians to degrees. I typically don't bother to remember all of this stuff. I have other things that I have to keep in mind, so I don't do that. This is where what we do is we will import a library that will help convert between degrees and radians. What is this library called? There are many libraries. One of the libraries that we can use, so I'll make that note, we can use the math library, which comes as standard library with Python, or the NumPy library. Okay, it really doesn't matter. The code is exactly the same. It's what you are importing that is changed. All right. So what I'll do is I'll import math. Now, so and then I'll show you how this is implemented. So now I have to ask for the stress vector. So asking user for stress vector magnitude and angle. Okay, so what do I do? So I say I write stress mag equals. Now comes a very important part. I am going to ask the user for a value, but I have to tell the computer at the same time what is the type of the value. Is it a string? Is it a number? If it is a number, what kind of a number? Is it an integer? Is it a float? Is it something else? In this case, when we work with numbers, we typically prefer float so that we get a wide variety of choices. Enter magnitude of stress. Okay. And now the question is, what is going to be the unit in Newton per meter square? All right. So Newton per meter square. Now, if you are familiar with LaTeX, during the main course, we would never write this as Newton / meter caret 2. We would actually use LaTeX to kind of print out how that is done. Okay, so now I have to make sure I've closed all the parentheses properly. I have not. Space, that. Now, the next piece of information I need to do is the angle. Now, put acute angle between the stress vector and the plane in degrees. Okay. Close parenthesis, close parenthesis. Okay. Now I have to convert the angle. Degrees to radians. All right. So how do I do that? So now I say angle in radians is equal to math dot radians. That is how you call the conversion function from the library. So math dot radians means from the math library, find the method radians. Okay. And then I have to pass an argument through that method. What is the argument? Whatever that I am trying to. I've already found a mistake. I'll keep that mistake to show you how Python shows you mistakes. Okay. Angle underscore radians is so and so. All right. Now I am calculating the normal stress and calculating stresses. So normal stress equals stress mag times math dot sine angle radians and the stress equals stress magnitude times math dot cosine of that angle in radians. All right. So my calculations are done. Now I have to print. Okay. So for the printing statement, I can simply say print, and then I'm going to create an F string. And in the F string, I'm going to say for a stress vector with magnitude stress mag, making an acute angle degrees the normal stress on the plane is, I mean, as if you're writing an answer in your, notebook or something to record whatever you have done. You would say normal underscore stress Newton per meter square, and the shear stress on the plane is shear underscore stress Newton per meter square. Close that, and then close that. All right. Now, what I'm going to do is we have written, a nice little program. I'm going to run this. So it asks me for some value that I have to put in. Let's say I'm going to put in 50. Okay. And that's the magnitude. Then it tells me that I have made a mistake. See, it says name error and it says trace back. And then it gives me this arrow kind of telling me where I have made the mistake. Now, this is helpful, but not always correct. What you have to do is when you get a name error or trace back, you look for this arrow and you look for what the error is telling you. And it tells you the name error name FLAOT is not defined. Well, I meant to write FLOAT. So you can see that, and this is where Jupyter Notebook or these IDEs become very helpful. See, OAT was in green, okay, because Python recognized that as one of its keywords. Okay, remember the keywords that you can't use as a variable. Anytime you write a keyword in Python, it shows up in a given color. Okay, so if I switch this O and A, without deleting. So now I think my insert key was on. Yes. So now it immediately recognizes these things and does that. Okay. So now I save this. Well, I didn't. And now I've made the change, and then I do this again. 50. Now it asks for that angle. I put a 30-degree angle, and it tells me for a stress vector with magnitude 50, then I could have put in the units. I did not. You can put it in. Making an acute angle of 30 degrees. The normal stress on the plane is 24.999996. Now that looks really ugly. Okay. I don't want it like that. I want to do I want to make it look a little pretty. So I'll just go over there to the normal stresses, and then I will just say 0.3F. For the shear stresses, colon 0.3F. Later, I'll show you, if you sign up for the course, how we can represent this in scientific notation. Okay. So if I execute again, so I'm going to put in the same values. So now you can see that the values are much more nicely shown. So you have a 25 point, because it was 24.99999996. So it rounded that up. Same thing for the shear stress, was 43.3101 and so on and so forth. Now you would say, well, this is very simple. I could have done this as well. Well, what if you have a variety of magnitudes and you need a variety of normal stresses and shear stresses? So let me describe two situations to you. One situation is you have 500 planes on which you have measured 500 stress vectors, and you need for each of those planes and vector couples, you want the normal stress and the shear stress. Or turn the problem around. You have 500 planes. On each plane, you know the shear stress and the normal stress, and you want to find out the magnitude of the magnitude and the angle of the stress vector. Okay. Now the problem suddenly becomes a lot more challenging, because you have to do this repetitive thing over and over and over and over and over again. Okay. Now this is where what in Python we use is called loops. Okay. So that is repeat a set of instructions within the loop. Now, in Python, loops are of two kinds. You have the for loop and you have the while loop. Okay. The for loop is controlled by numbers. The while loop is controlled by conditions. Okay. So let us see what we can do if we try to calculate the normal stress and the shear stress for that same vector as the angle changes. Okay. So what I'm going to do is I'm going to steal the same program from above. I'm going to steal this program from above. I won't copy the printing part. And now, once these values have been provided, actually, I don't care about the angle. I can just put the angle. I can put the angle. My angle is going to vary between 0 and 90. Okay. So I am going to say my angle varies between 0 to 90. All right. Now, there is an interesting way to show that. Angle equals I can say angle equals 90. Okay. So now what do I have to do? I have to generate a loop. A loop. So what I would do, I'd say for angles in range 0, angle plus 1. Now you would say, what is this? Why angle plus 1? This is where you will learn that Python counting starts at 0. Python 0 is what we consider 1. So 0 to us humans is a number which has no value. But to Python, the character 0 has a value. So it considers it as an element. Okay. So I am saying that I'm going to go between 0 to angle plus 1. And the other thing about Python is, excuse me, that it always goes one less. When you put things in a loop, it goes one less. Okay. So then I I set up the for loop, and when I press enter after this colon sign, I get a tab. This is called indentation. Again, we will talk about all of this in the course. I just don't have time to talk about all of that. So then what I can do, I can say that my conversion of the angle is going to happen here. What is the conversion? The conversion is angle dot radians is equal to, what is the iterator here? The iterator is angles. So angles. Okay. Then my stress calculation is going to happen here. Okay. After this tab. So all of these are going to go in like that. So the normal stress is going to be so on and so forth every time. Okay. And then I am going to do the printing. And this printing is also going to happen here. And I am going to just print very quickly something like this. We are almost out of time. We are going to say that for stress mag stress underscore mag, and angle would be angles degree normal stress is normal underscore stress colon 0.2f. I'm skipping the units just to kind of in the interest of time. And your stress so stress point. All right. Now, what will happen if I run this code? Well, let's run this. So again, we are interested in the magnitude. So I'm going to put in a magnitude of, I don't know, maybe 100, just change the values around a little bit. Now, once I hit enter, you see, this is the fancy part about that. I have just modeled for a magnitude of stress of 100 Newton per meter square on any given plane. If the stress vector is parallel to the surface, what the normal stress and shear stress are going to be, to all the way. So here is the thing. So you can see for stress mag 100 and angle 0 degree, normal stress is 0, obviously, because the entire stress is parallel to the plane. Shear stress is 100. But then see, the angle has changed 1 degree. Then the normal stress is 1.75. The shear stress is 99.98. And it starts to change. And all the way, if I go all the way to the bottom, you will see for a stress magnitude of 100 and angle of 90 degrees, what are the values? Now, this is also very interesting. You see, I originally put in the code angle plus 1. What is angle? 90 plus 1, it should be 91. You would expect 91 to be the last value, but no, that is not the case. This is one of the quirks of Python that you want to be aware of. Okay. Now, what could we do with this? It would be fantastic if we can plot this, but we are out of time. So that would be the very first thing that we would do, is get into visualization tomorrow. Okay. Now, do people have any questions? I think there is a question.